Welcome everyone to the fifth workshop of the MIST101 series, Unsupervised Learning and Clustering. Before getting into the topic for the workshop, let's look into what was taught in the previous section by Nick. So he went over two biggest causes for poor performance of machine learning algorithms, that are overfitting and underfitting, and also talked about the ways to avoid overfitting. For recap, overfitting is a good performance on training data and poor generalization to other data, whereas underfitting is poor performance on training data as well as poor generalization to other data. So let's get into the topic for this workshop. So this is the outline for the workshop. We would be covering what is unsupervised learning, why do we use it, the difference between supervised and unsupervised learning, types of unsupervised learning, what is clustering, principal component analysis, K-means clustering, its algorithm and application, as well as applications and disadvantages of unsupervised learning. So let's start by answering the question, what is unsupervised learning? Unsupervised learning is a machine learning technique in which the users do not need to supervise the model. Instead, it allows the model to work on its own to discover patterns and information that was previously undetected. It mainly deals with unlabeled data. Let's take the case of a baby and her family dog. She knows and identifies this dog. Few weeks later, a family friend brings along a dog and tries to play with the baby. The baby has not seen this dog earlier, but she recognizes many features like 2 ears, eyes, walking on 4 legs, which are similar to that of her pet dog. She identifies this new animal as a dog. This is unsupervised learning, where you are not taught but you learn from the data. In this case, data is about the dog. Had this been supervised learning, the family friend would have told the baby that it's a dog. Unsupervised machine learning purports to uncover previously unknown patterns in data, but most of the time these patterns are poor approximations of what supervised machine learning can achieve. Additionally, since you do not know what the outcomes should be, there is no way to determine how accurate they are, making supervised machine learning more applicable to real-world problems. So why do we use unsupervised learning? There are various reasons. Unsupervised machine learning finds all kinds of unknown patterns in data. Unsupervised methods help you to find features which can be useful for categorization. It takes place in real time, so all the input data has to be analyzed and labeled in the presence of learners. It is easier to get unlabeled data from a computer than labeled data which needs more manual intervention. So differentiating unsupervised learning from supervised learning. Supervised learning algorithms are trained using labeled data, whereas unsupervised learning uses unlabeled data. Supervised learning model takes direct feedback to check if it's predicting the correct output or not, but that's not the case with unsupervised learning. It does not take any feedback. The supervised learning model predicts the output, whereas unsupervised learning finds the hidden pattern in data. In supervised learning, input data is provided to the model along with the output, but in unsupervised learning, only input data is provided to the model. Moreover, supervised learning model predicts an accurate result, and unsupervised learning model may give less accurate result as compared to a supervised learning model. So these were the differences between unsupervised learning and supervised learning. Now let's look into the types of unsupervised learning. The types of unsupervised learning are clustering and association. So clustering mainly deals with finding a structure or pattern in a collection of uncategorized data. Clustering algorithms will process your data and find natural clusters or groups if they exist in the data. In association, the association rules allow you to establish associations amongst data objects inside large databases. This unsupervised technique is about discovering interesting relationships between variables in large databases. For example, people that buy a new home are most likely to buy new furniture. Our main focus in this workshop is clustering. So to know more about clustering, let's look at that in our next video.